Section 11.2, Algebra of Matrices, Part 1. Two matrices are equal if they have the same entries in the same positions. Two matrices are equal if they have the same entries in the same positions. When we look at here, in order for these two to be equal, they have to have the same entries in the same positions. Now what we're going to do here is look at what this 3 means. This 3 is called a scalar. It's just a number or a constant that we multiply a matrice by. What we do with the scalar is we multiply everything on the inside by that scalar. So this actually reads 3x, 3y, 3y, 3x. What we have here is every entry inside the matrix multiplied by this scalar 3. Now, for these two to be equal, we come back to our definition, which is they are equal if and only if they have the same dimension. Okay, they're both 3 by 3, and corresponding entries are equal. Corresponding entries are equal. So let's look at corresponding entries. Corresponding entries, this 3x is going to equal 6. This 3y is going to equal -9. Again, this 3y is -9, this 3x is 6, and so here's how we can solve for x and y. We know corresponding entries have to equal, so we're going to take 3x equals 6, dividing by 3, we get x is equal to 2. Corresponding entries equal, so we have 3y equals -9. If I divide both sides by 3, we get y is equal to -3, and that's what they want as our solution. X equals 2, y equals -3. Okay, that would be called the scalar product of matrices. If we look at the scalar product, every constant or scalar is multiplied by every entry inside of the matrix. Okay, if we want to look at add or subtract, all we have to do is add or subtract corresponding entries, and that's all we have to remember for sum and difference of matrices. Add and subtract corresponding entries. Now, later we're going to learn how to do this in our calculator, but adding and subtracting, it takes more time to put those entries into our matrix than it does just to do it by hand. So we're not going to do sum and difference using our calculator. It takes more time just to get that matrix in there than just to do it by hand. So we're going to do these by hand. Okay, so we want to perform the matrix operation, or if it's impossible, explain why. Okay, so why would it be impossible? Both matrices have to have the same dimensions. If both matrices do not have the same dimensions, then we can't add or subtract. To add and subtract, A and B have to have the same size. Okay, so here's, if we look at matrix A, here's matrix A, we've got 2 rows, 3 columns. Here's matrix B, we have 2 rows, 3 columns. They have the same dimension, they have the same size, so that means we can add them together. Okay, so all we have to do is add and subtract corresponding entries. 0 minus 2 is going to give us a -2. 1 minus 1 is going to give us a 0. 1 minus -1 is going to give us 1 plus 1, which is a +2. 1 minus 1 is going to give us a 0. 1 minus 3 is going to give us a -2, and 0 minus a -2 minus a minus would make that 0 plus 2, which is 2, and there's our subtraction of A minus B. The dimensions or the sizes have to be the same. When we look at our result, the result will be that same dimension, that same size. Okay, so we got to take care of the scalar first. Remember, with scalar multiplication, everything inside of our matrix has to be multiplied by the scalar. So that would be 2, 2, 0 times 2 is 0, 2, 0, 2, 0, 2, 2. Every entry inside of that matrix is multiplied by 2. Then we have 1, 1, 2, 1, 3, 1, and we would start adding, but before we go through all that work, remember the most fundamental thing is in order to add or subtract, these have to have the same dimension. They do not have the same dimension, so addition not possible. Okay, what happens if we ignore that and we try to add together? Notice 2 plus 1, we're okay with 3. Remember, to add or subtract, we add or subtract corresponding entries. 2 plus 1 would be 3, and then when we look at 3 plus what? There's no corresponding entry, so there we have addition not possible. In order for it to be possible, these matrices have to have the same dimension.